Right, so today we are going to look at the motherboard and the startup procedure for our computer. After that, we will be done for the day. So it should be a very short and compact lesson. Then we will get a chance to revise everything that we did this week, so that next week on Tuesday, we can discuss what we've covered. Just housekeeping. Let's mute our audios as soon as we end the meeting so that we don't interrupt the proceedings. Thank you very much. So today we are going to look at the motherboard and the startup procedure for our computer. These are the only things that we are going to look at today, and we'll call it a day. Right? So that is the pictorial view of the motherboard in general. I think I talked about it in the previous lecture. So we're going to look at a few things that need to be explained slightly so that we can move together with the same pace. Right. So I'll start from the left corner, right round, and explaining slightly what each component is. Like I said yesterday, this is a generic motherboard, and you can see variations in these things, but the basics are basically the same. So the first thing that you have to take note of is that there is a CPU circuit. This is very different from any other circuits. Why? Because the CPU socket basically has the largest number of pins. You can see that those are the holes in which the socket, the CPU will be sitting, and you can see there are a lot of them. So on all the components on the CPU, on the motherboard, the CPU has the largest number of components. And on top of that, the CPU is seated onto those holes so that you don't put much pressure. So if you look at this white thing, this thing, it is a jack. So you lift it upwards, right? After lifting it, it opens these holes. Now, the configuration of the holes inside that, there's one side which is a blank corner. If you look at this one, this small triangle, there are no pins. But if you look at the other corners, you find that there are pins right round. So why do they put this one? So that if you sit it wrongly, no pin will get into the holes. So until you sit it properly, then it will get in the holes. So once you sit it properly, then you just push down that jack, then the CPU will be fixed onto the position. So this mechanism is so that the CPU can be plugged in without exerting pressure on the CPU, 1. 2, without touching the top of the CPU, because if you touch the top of the CPU, you might cause electrostatic electricity, and that will also affect your CPU. So that's basically the CPU circuit. So that is the first thing that should look for when you see a motherboard. You should find the CPU socket first, right? Then after that, there is the CPU and fan heatsink mounting points. So this point and that point, there are also points here and there. Those are the points where the CPU fan and the heatsink are mounted. So the reason why we need the heatsink is so that when the heat is produced from the CPU, then the heat gets into the heatsink, then the fan will blow away the heat. So there's allowance of air to circulate so that heat is taken away from the CPU so that it doesn't heat so much. So I realize that if your CPU fan is no longer working, it will not take more than a minute before the computer shuts down. That is the mechanism, so that the CPU does not get destroyed by the heat. Then there is the ATX power connector. the ATX power connector. So ATX simply means advanced technology extended. So this is the improvement from the advanced technology design of the previous motherboard. So the X is just an extended technology, right? And the AT is the advanced technology. So this is where the power sockets from the CPU power supply are connected. Again, they're arranged so that you don't do a wrong connection. So most of these things, they give you a guide on how to connect them. Then close to the CPU, that is in most of the cases, the slots that are closest to the CPU, normally they are the RAM slots. So this is DRAM, the dynamic RAM memory slot. So normally, these slots which are closest to the CPU, in most cases, are the RAM sockets, right? So you can see what we say the CPU operates together with the memory. So I think even the physical distance between the two is also minimized by that. Then we have the IDE drive connectors. So IDE just means integrated drive electronics, right? It's an for connection hard drives and other storage devices. So you realize that a hard drive, it is a cable, and those cables are connected on these sides. So you might have two hard drives, or you might have a CD-ROM and a hard drive. So these are the points where they are connected. Then there's what is called the NOT bridge, which also has a heatsink. The NOT bridge, it gives a direct connection to the CPU for faster components like the graphics cards. So this NOT bridge is directly connected to the CPU. And so it gives the communication control for the fast components, like the graphics card, it needs a speed. So again, it is connected through the NOT bridge. And this is the AGP slot, which is actually a graphics port for AGP. So this is the one for the graphics card or the video. So you can also see there's a reduction again in the physical distance between the two. So information comes from the CPU into the NOT bridge, then from the NOT bridge into that slot. Then the card is connected there. Then there's also the south bridge. Now, the south bridge, it connects to the slower components of the computer systems, and it is not directly connected to the CPU. So the south bridge is connected to the CPU via the NOT bridge. So we have information coming between the CPU and the NOT bridge. Then from there, it also goes to the south bridge, then to the other peripheral interfaces, which don't require much speed. That's where the south bridge gets its services. Then the last thing we might need to talk about, which is very important, is the CMOS battery. CMOS simply means complementary metal oxide, right? So this semiconductor which is used there, the battery gives the backup for other computer information. So that's why even if you power off your computer, when you turn it on, you still have the correct time and other details. It's because that is serviced by the CMOS battery. So if your CMOS battery is now flat, what it simply means is that whenever you turn on your desktop computer, it will have a wrong date. Then at the back, these are other peripheral devices, right? You see for the mouse, the USB cards, the Ethernet, and the audios, and so on. And this is for the screens, the monitor, and the like. So these are connected through these sides. So other additional cards will be connected on these slots. So that's basically the layout of the motherboard. That is the layout of the motherboard. Right. Then we look at the motherboard, the BIOS and the POS. The external data bus connects devices on the motherboard together. So when you start saying external, we are saying all those connections that are not within the CPU that are taken to be external. So from now onwards, when we talk about internal and external, we are talking about things that are either in the CPU, that's internal. Anything out of the CPU is external. So the external bus, the one which connects devices together in the motherboard. Everything is also connected to the address bus, and these buses are physical connections. So you would want to call them connection lines or wires. That is the bus that we are talking about. Those connections is there. Bus, which you can get there. Okay. So those are the connections that you can get. Then after that, the CPU devices now, you need, the CPU will need to connect with other devices, and therefore it also needs a form of software to be able to perform that, and that software is the BIOS. So BIOS, it is the program that allows communication between the CPU and the devices. So BIOS, which is basic input-output system, is stored in the read-only memory, and it's a permanent chip on the motherboard. So that one, which I showed you the other day, and I said that is the ROM, that is where the BIOS is stored, right? So BIOS is a software and ROM is a hardware. So we are saying the BIOS resides inside the ROM, right? So there are three kinds of BIOS software for hardware devices. So there's permanent BIOS for permanent hardware, and that is never changed. It is stored on the ROM chip. Example is the keyboard and BIOS. So the software that enables the communication between the CPU and the keyboard, the initial communication is allowed by the BIOS, right? Then there is hardware that changes occasionally. This requires extra volatile information, so it might be stored on a separate chip called the CMOS. Right? So like I said, there's a CMOS battery, and the CMOS battery gives service to the CMOS chip. And that CMOS chip, it needs power because we said it's volatile. So the purpose of the CMOS battery, which I was showing you now, is that the CMOS chip does not lose its information. So the example is the RAM, like hard drives and the floppy drives. So this one, the information is stored on the CMOS, the BIOS for that. Then there are other devices. There's BIOS stored in the devices, example, the sound card. So a sound card comes with its own BIOS. That means it has its own software that gives it instructions on how it should perform. There are also devices where you have to install the drivers so that you can ensure communication. So there are other components which are not basic to your computer system. So when you want to use them, they need drivers. So a driver software, it's almost like the BIOS, but now because it is specific to a device, you have to install it, right? So like if you connect, let's say, a USB cable, then it has to install the drivers first before that component can communicate with the computer, right? So the first group of the permanents, the BIOS, is called the firmware, since it is software that does not change. So even if you look at your phones, you hear about firmware. That is the permanent programs that you find in your phone. That will never change, right? That is what we call firmware. It is stored in non-volatile memory, the ROM. I talked about this. The newer flash ROM enables users to change this ROM. So there is also some ROM which allows the user to modify. That is flash ROM, right? Phoenix and MI are the most common brands in these permanent things. Then the CMOS for the devices that can change. CMOS stands for complementary metal oxide semiconductor. It stores information that is updated so that the CMOS, remember I said CMOS is volatile, also acts as a clock to keep time and date. I think I talked about this. Then the CMOS, you can enter it by pressing F1 and other combination of keys. That depends on the type of computer that you have. So when you enter the CMOS, you are saying you want now to modify the settings. Since they are in volatile memory, you can modify them. Then it's powered by a separate 3-volt battery, usually lithium rechargeable. That is the CMOS battery which I was showing you there. Then, if device does not support a device, you can add the device driver, which comes with a disk. These days, you can actually download device drivers from the internet. For those programs, you can use config DOSys to add BIOS. Well, this is slightly more advanced. When you go deeper into computer engineering, you will be able to put those commands to do some of these things, right? But for higher versions of Windows, like once we have the Windows 8 and 10 now, they automatically store most of the drivers so that you can actually, when you plug the device, then Windows will pick it and install the necessary drives. That becomes what we call the plug and play devices, right? So there is a registry, right? This registry now, it comes with initialization files, which are found in DOS and the upper Windows. Remember, these days, DOS is what you now call the CMD or the command prompt, because most computers don't use it so much, unless if you have special things that you want to do on the DOS. Then if you need to edit the registry, you run the command edit.exe. Well, you might not do that, right? You have a control panel, and most of the changes can be done there. So with the newer Windows that we are now using, there's a control panel. You go to the control panel, you can modify whatever you want to modify. You can also go to the device manager and modify what you want to modify. You don't necessarily need to enter these commands. But then I'm just talking about it so that you can see that before the advent of the graphical user interfaces, this is how people used to put commands into the computer system. So there are some words which we want to talk about. Post, that the power on self test. That means when you introduce power to a machine, right, and you push the power button, the computer will undergo its own power on self test, right? So the post is stored in the ROM chip and runs every time the computer is turned on, like I said. So it is during this post that all devices are instructed to self-check. In other words, when you power on, the first thing that happens is the post will instruct every connected device to confirm that that device is working properly. If one of the devices is not working properly, that's where you see errors like IDE not found and the like. That means it will have tried to access that device and realize that it is not working properly. So it first checks the basic devices. So when we talk about basic devices, we are looking at the CPU and its associated cards, and then we also look at the keyboard. So realize that when you switch on your machine, the keyboard will come and give you some indicators showing that it is working properly. That is the self-test we are talking about. Then the rest of the devices are run and error codes are displayed to indicate if there are any problems. So the post cards can be used to check up on a problem that post check has detected or caused. These days, you can check it on the control panel again and you can do whatever you want to do there. That is if you get in the Windows. If you don't, you get into the startup menu and you can do all these things. So basically, these cards are no longer normally being used. Right. And can someone mute their audio there? Disturbing. So we look at the boot process. How does the computer boot itself? So when we talk about the boot process, we are just talking about the startup process of computer. Can someone mute their audio there? Right. The boot process, this is the process which makes us end up being able to use the computer system. So we are saying the computer is booting, we are saying it is the total startup process. So when you press the power key, right, the CPU wakes up. That's the first thing. So the charge that comes the CPU, it wakes it up. When you say it wakes up, we're saying the CPU is now ready to work. Then you run the post with the power on self-test. Then if there are errors, they are checked and displayed on the screen. Then the plug and play devices are searched for and configured if needed. So when you say about the plug and play devices, we're talking about those devices which once you plug them to the machine, the Windows will pick them up, run their, install the drives, and then it starts working. Then BIOS begins its search for operation system, or the operating system. So in the operating system, we'll talk about it later, this is where we find a boot sector, right? So this boot sector will start up the operating system. Then after that, it starts working. So in previous devices, it would check the floppy disk first, then it goes to the hard drive. But these days, the modern computers, because most of them don't have the hard drive, it will check, don't have the floppy drive, it will check the hard drive. Then if it doesn't find anything, it also tries to check from the CD-ROM and any flash devices connected, right? Then the operating system takes control, right? So after the BIOS has run its course, it gives over control to the operating system, right? So that is what happens during the startup of the computer. So we now look at the motherboard, the layouts, the way the components are on the motherboard gives us what is called the form factor. Then the two types are the advanced technology and the advanced technology extended, which I talked about previously. AT uses the older ones, and then the other versions, maybe AT, which was smaller. And then there's the ATX, which uses the P1 power connectors. So that's basically what we have in terms of our motherboard and it's the startup of our computer. So this brings us to the end of our lecture. I don't know if I have any questions. You can unmute your audience if you have questions before I run out of time.
Good morning, sir.
Can I ask?
Yes. Can go on.
Okay, good morning, sir. Yes, I wanted to find out. Let's say when I switch on my laptop, it starts telling me a battery, something about the battery not working, something like that. Is that because of the CMOS or what? Like when I power it on, just I don't produce a white and black screen, which tells me you need to get a new battery or something like that.
Yeah, during the self-test that it will be running, it also checks the charging system and it also checks if your battery is charging. So normally if your battery is not charging, the battery will be flashing continuously. So that's when it will tell you that maybe you need a new battery or so on. It's not the CMOS battery.
Oh, okay.
Because if the CMOS battery is not working, it will give you the wrong dates and the like, then you know it's the CMOS. But if you still find the correct dates and the like, then it means it will be your battery. So what it does is, when you are connecting a charger there, it checks the battery to see if it is working properly. If it's not working properly, then it's flashing.
Okay, thank you, sir.
All right. Anyone else before I end?
So can I ask where we can find the notes?
The notes are on Piazza.
Okay, thank you, sir.
Yeah, you go on resources on Piazza, then you find the notes there. If there's anything else, I'll be uploading it on Piazza as we go. Okay, anything else? All right, thanks guys for your time. Let's go and revise what we've talked about. Then we'll discuss in detail on Tuesday next week. And
thank you, sir.
The lecture ends here. Okay? Bye.
Thank you, sir.